Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Well, let me get next to the microphone. Okay, again. So I have the pleasure of introducing Hee-Dong Ko here from Korea Institute of Science and Technology. He's heading the Imaging Media Research Center in over there. We met last summer. I was giving a presentation in Pyeongchang at the Korea Computing Congress, and we decided that we have some common interest in the ubiquitous computing space, and so now that Hee-Dong had a chance to come over here, I thought it would be cool if he would share a little bit on what they are doing and what they are planning on doing, and then we can talk more later. So, please.
Hi, good morning. Today, it's a pleasure for me to give a chance to give a seminar here at Microsoft Research. As you can see, it's not a very specialized technical talk. It's more of a general introduction of research that is going on at our institute called KIST. And at first, I'll give you an introduction of the institute and my organization. And then, as the title of the talk, I'll talk about the TSI concept, the Tangible Space initiative that our institute has started. It's almost 4 years now. And various projects under this TSI concept, mainly the digital heritage exchange, digital contents related project that we've done before. And then the current project, which is immersive tangible experience, mainly VR related research. And then the context-aware multimodal interaction that Johannes introduced me a little earlier about Ubicom. And then I will conclude the talk. KIST was established about 4 years ago, in 1966, with an agreement between Korea and U.S. Then the President Park Chung-hee and Lyndon Johnson. So it is one of the earliest modern research organization in Korea. Through a long history, we've gone through as many changes. The biggest one is '81 when we were combined with KIST, which is a educational institution that was organized in the '70s. And we became both research institute and educational institute. And the combined institute is called KIST. And then in 1989, we decided the marriage was not successful, and we split. We became a research organization as previously as KIST, but the KIST decided to keep the name of KIST. So the KIST now is an educational institute, and KIST is a research institute. And some of you may have heard about KIST more recently. And the KIST has been a mother place of many of Korean research institutes, numbering tens of them, and it's not a particular. It's a comprehensive disciplinary research organization, including material science, chemical engineering, and many other all kinds of areas, including IT. More focused on IT more recently with the TSI project. We have a annual research budget about $140 million, and most of the money coming from government-sponsored projects. About 46% is our own fund that is secured from the government annually. That is from the budget planning office, and the others are sponsored projects, mainly called for by the governments for specific mission. And we have about 654 regular members and 400 research scientists. Well, even though we split in '89, students became a more stronger part of the research activities at KIST, and now we are totaling over close to 700-800 students are involved in research projects. And we have part-time research assistants as well. So the whole campus is occupied by more than 1,700 people. Our center was established in about 97, 9 years ago. The main research scientists are about there's 7 people. They are the core of our center, and we have about 40 members, including students, in our center. The main research areas that we can classify into 4 areas. One is interactive relative display technology, which is mainly large screen, multi-channel immersive displays, and 3D visual displays, autostereoscopic displays, and tangible media, which is mainly 3D virtual environment related, and some Ubicom activities under this area. Reality sensing and imaging is mainly by one of our staff member who is involved in electromagnetic imaging, and we are bringing those activities, imaging technologies, as part of the mainstream of our research, interaction research. And digital culture exchange technology, which is mostly content-oriented. So these are the main areas that we are involved. The TSI concept is, as you all probably aware, that in the 90s there were sort of 2 paradigms of interaction. One is mostly simulated within computers with some novel 3D interaction gadgets for HMD and cyber gloves and other tracking devices to have the cyberspace more realistically presented and interact with. The other would be more in the Ubicom related activities where the physical space is being embedded with computing and networking capabilities and becoming more responsive. So these two sort of trends of interaction is mature enough to think about some merged and more uniform approach to interaction in general. And the TSI concept was initiated about 4 years ago in our institute when we thought about how we organize our research under some common theme. And the institute was very keen on shifting the main, one of the they initiated 5 focus areas of the institute. And one of them was an IT area, and the HCI, human-computer interaction, was one of the focus areas to pursue in IT area. And we talked long and hard about what would be a sort of common theme under HCI umbrella. And we thought this background that I mentioned to you was motive, and we sort of come up with this concept TSI, tangible space. And it's basically we need to have a seamless interactions either with computer-created, generated virtual environment, as well as everyday physical interactions in physical environment. But they tend to transcend to one to the other and back and forth, instead of they are being separated and dealt with completely in different context. And our research staff, the members have various backgrounds, especially in mechanical engineering and robotics. And our center was mainly on software and contents a little bit. So we decided to have this concept, TSI. And we've been doing this for the last 4 years. And we feel we identified 3 major components to realizing this vision. Mainly the computer-human interface, we call it tangible interface, that needs to be more realistic and more tangible. And that's what we call tangible interface component. And then there's the traditional cyberspace, but more toward intelligent interactions that is more akin to human needs and intentions, rather than just being reactive only. Because as information gets more complex, all the manual interaction is overwhelming, and this is a needed direction that we felt. And then there's a tangible agent, which is many coming from the robotics people, where the purely cyberspace cannot deal with some physical realization of its own intentions. That is, if the cyber agent wants to do some actions in the physical world, it has to have some sensors and actuators to sense and act in the physical environment. And we call this notion tangible agent. It's a little bit different from just regular robotics area where in robotics they're more focused on autonomous agent that is intelligent and doing its own thing. But in tangible agent, we are more focused on interactions that are realized in physical environment. So all these three components added together and create a seamless interactions from physical environment to virtual environment and back and forth. So obviously we are physical being. We exist in physical environment, but we interact with cyberspace through some interface devices. And with a desktop metaphor, it's been mostly successful by Microsoft. But as with more realistic virtual environments that are being commonplace, we need more tangible interface that can communicate with human in a more natural way. And as well as the tangible agent, which senses and act on behalf of cyber agent in the information space. So the TSI project is focused on these four application areas. We call it digital life in physical world, either in office or in some design review or at home or some cultural experience. These are not exhaustive lifestyle, but these are the main application areas that we are considering. So let me start off the cultural applications, the cultural life space. And we focused our initial interest in cultural life was our company-sponsored project that our center was involved in 1999 with Gyeongju World Culture Expo, and that later has been expanded to very nice international cooperation with the European Union on their IST project, and we named it DHX. It's more of a network-based tele-immersive presentations of virtual environments. And there's a what we call a TAIN project that connects the Europe to Far East with a high bandwidth networking capabilities. And they needed some applications that make use of high bandwidth networking. So the DHX was a nice application for that kind of high-speed internet networking capabilities. And there were 7 institutes were involved in our KIST in Far East, and there were 60 institutes. The main one was Fraunhofer in Germany. The St. Augustine-based INK, and Barco in Belgium, and RMH, Canuce in Italy, and University of Milano in Italy, and University of Crete in Greece. So the TAIN network connectivity was being established when we started the project, and now it's well established and running in hundreds of megabits now. As I mentioned a little bit earlier about 1999 project, that was World Culture Expo 2000. So the millennium was, there are a lot of cultural projects all over the world. And the Korea has a long history. The main capital city in the old days was in the southern part of the peninsula called Gyeongju, which is the main area where they had the World Culture Expo 2000. And we built a, what they already had a large theater, which we renovated all over to make it more VR theater out of the conventional performance-oriented theater. It was about 1.5 years effort, costing over $3.5 million. And we opened the theater in September 1st, 2000, and run for about 3 months. As far as we know it, this was attended by 1.7 million people, and it's one of the sort of largest number of people who have seen immersive VR contents. It still is. And this is the exterior of the theater, and it's 36 meters square with a height about 10 to 14 meters high. So it's a pretty huge place. And the interior of this, what we call cyber image hall, we had at that time, one of the fastest graphics computer we could find, which was SGI Onyx 2 with infinite reality engine with 6 pipelines. And we ran the brightest digital projector we could find because it was very big screen. The screen was 27 meters wide, about 10 meters high. So we used 6 projectors to fill it up with a stereo. So so a large number of people could see stereo in an immersive way. And we instrumented something. We as researchers want to do something different, so we put the keypads in all the seats. We have over 600 of them, and each seat can control the. It's used as just like a mouse, so everyone can control it essentially.
So what do you control?
The contents.
Okay.
Yeah. Basically the navigation. Yeah.
So they vote for navigation or something?
Right. Right.
Yeah, because 600 opinions is a lot.
It was interesting to how it comes out. We tried some maneuvering of butterflies. I'll get to that a little bit later. So as you can see, this is a display screen, and it's a stereo.
Oh, you had an aroma control system. Does that mean that you actually also produce
Right.
like coffee smell? Or,
Right. A charcoal smell, pine smell. There are about 5 or 6 varieties that we could control.
So how did people like that experience?
Yes, yes. They felt the sort of the smell gives the enhance the immersiveness of the visual realism. But it's a large space, so we couldn't use very many displays of aroma.
Right.
Because it takes some time to dissipate and circulate. So we just used about 3 times, I think.
Right.
So this is the keypad we designed. You could basically use 4-directional control and 2 buttons for meta keys.
So this was screwed to the seats?
Yeah, each
Right.
seat was as, and there are 3 colored keypads, so that we can have sort of 3 groups in the audience that they can have a sort of a same role for grouping
Were they
them.
randomly distributed or?
It was more of sections.
Okay.
Yeah. Now this is the casing was installed in each seat, and this is one of the snapshot of the during the audience presentation, and it was polarized using we used polarized stereo, so everyone has to have this glasses, and it was stereo, so they could actually, we could have images pop out, and I was interested to see some children actually trying to grab the images running around the theater.
Oh, really?
Yeah.
So did you have trouble when you had multiple projectors, like the scenes, did the stereo work of the scenes?
Right.
Also, or?
Right. That was actually the main conditions we've enforced when we purchased the projector. That the scene has to be seamless.
Right.
It's actually very low tech.
I see. Okay.
This is sort of a monitoring system. We have 651 seats, and all the seats were being monitored with operational and monitoring the user input. So it was interesting to see the type of audience interactions as opposed to distributed interactions when multiple people come in with their own computers and chat peer-to-peer. This is one single scene that is shared by all the audience members, and then they participate in the interaction together. It's a kind of a different type of interactions we have to consider in this kind of situation. And the voting is obviously one of the ways we used for controlling the group interaction. And as you can see, the butterflies, the group of butterflies being controlled by those 4 directional keys, and the audience members together can vote for each directions, the 4 directions, back and forth, left and right. And we showed this 3 times, and initially, the first time, people didn't realize what it's doing. But by the second time, they were able to control it. They learned it. And they were able to collaborate to make the
Is there ever any explicit instructions?
Yeah, the buttons were explained before the previous section. We had a previous session that explains the what they are showing in the theater, and but we don't specifically say at what time these butterflies show up and so on, but we just give the explanation of functionalities of the keypads, and they were able to learn it. And when we initially designed into this contents, we were a little bit afraid that there are so many people voting and maybe love large numbers and things will just centered in the middle, canceling each other. But they didn't like that. They like to move things around, and they collaborate to achieve that. So that was an interesting observation.
So how did it work when you saw that everybody else was moving left, then you would go left too? So it's like the lemmings. Or,
yeah. So they, when they see some trend, they sort of enhance that trend.
Right.
Yeah. And this is a kind of an interesting interaction design perspective for why people enjoy stadiums, sports stadiums, rather than in-house TV broadcasting. We had an interesting experience with World Cup in 2002 when we had a very large display screens that were set up in large squares, and especially young people all gather in the plaza to see the World Cup in groups rather than at home. Although it would be very inconvenient for them to gather there, and the kind of group experience is sort of new areas of interaction for HCI. Okay, well, this is what I mentioned about distributed interactions. We have built sort of out of that experience, what would happen if we have a smaller scale but more controlled and dynamic and immersive environment. So we have a 4-seat motion bed in our in-house to control the group interactions, and it will be an effective way of designing content for group interactions. This is still ongoing, but we sort of we need some sort of leader among the group, and some guidance toward what to expect. And we have a teleguide who present the contents to the audience, although there are only 4 of them, and help them to achieve certain goals by giving some hints what to do. And this was sort of an afterthought of our cyber image hall experience. So this is sort of this person is a guide, and these are the audience members, and they are all sitting on the motion bed, so they can control the motion bed as well as they could control the contents. And the teleguide, this person, actually, it's a digital heritage, so we need a guide to help the audience to tour. So this person is helping them to learn about the content and giving them hints about what to do. And sort of that that helps to sort of have some sort of directness for the presentation of the content. Pardon?
Like what?
Some of the various science fiction stories.
Right.
Particular one I'm thinking of.
Which one?
Have you ever read Diamond Age?
Diamond Age?
Ben Neil
Diamond
Stevens.
Age?
Yeah, it's called the Diamond
Yeah.
Age.
Uh-huh.
Ben Neil Stevens.
Okay.
Yeah. Very reminiscent.
Uh-huh. Well, I think actually the movie people is ahead of us in terms of imagination, because anything that we could think of, there's some movie about it.
And of course the science fiction writers are the movie guys.
Yeah, right. But that also helps us to think about new things. So this is just the spec of the, and the group interaction with group navigation, where we have 4 people representing one group each by just single person each. 4 types of groups that collectively interact with the single contents. And we have a competitive interaction, what we call, they sort of compete with each other to win something. In this case, we put a lot of pillars in the pagoda to build the whole pagoda, and who wins it. Okay. And this is more of a guide-learner interaction, where the guide helps the audience members through the navigation and multi-group interactions. They collaborate to achieve something. In our case, they sort of the guide tells them to simultaneously press a button to start the journey, or something in part of the we put in and the contents. This is a very famous grotto in Gyeongju, which is World Heritage, and it's called Sakuram, and people cannot go in. It's no longer possible to see in person. We couldn't. We would love to get into the space to digitize the whole thing, but we were not allowed, even though the Ministry of Culture asked them to do it, but they wouldn't do it. So we finally digitized the scaled model, a quarter of that, in a museum. But anyway, this is the digitized version of the Sakuram copy.
Well, that's very protected, so nobody has ever digitized it.
Right.
But
Yeah.
What's the point of a World Heritage Site?
They were afraid they might hurt it.
Yeah, it's just
yeah.
funny, protecting the point of...
Actually, I heard that in France,
Yeah.
in France, they found some very exclusive findings, and then they digitized everything, and then they closed off the entrance
Right.
to preserve it.
Yeah.
Yeah.
Okay, that's pretty
Yeah.
interesting.
This
Point is-
this was closed off before the digitization. So.
Well, maybe that takes a little longer negotiation than another 5 years you'll pursue it.
The organizing committee of the Gyeongju World Culture Expo 2000 and the Korea Institute of Science and Technology, or KIST, co-produced A Journey into the Breadth of Sorabal.
This is a shortened version of the Gyeongju VR production.
The oldest Buddha statue is located in Namsan Tapgol, or Valley of the Pagoda. Namsan Tapgol was thought to be a holy site.
Actually, you'll see some engraving of a pagoda in a stone. And actually that is a pagoda that existed about 1,000 years ago, but it was burnt by Mongolian invasion.
Oh.
But that gives us a hint as to the structure of the pagoda, which was one of the tallest structure at that time. About 80, there's a different theories, but about 80 meters high. And it exists in a temple which was, according to the history, it's about 10 times the size of the largest temple in Korea.
Okay, so this is the stone carving of the
Yeah,
picture
one of the pagoda in the temple. Actually, the whole content actually go into this temple, but this video doesn't have that. But we show this pagoda because we get into this temple and show the actual virtual recreation of the pagoda. Although this video doesn't show.
In order to reach Wolsan, or Moon Castle from Namsan, we have to pass over a 63-meter-long Woljung-gyo.
So we didn't know at the beginning, but they usually had this kind of structure on top of a bridge for at that time, which was not shown before.
So that structure doesn't exist now.
Right.
Wolsan, or Moon Castle, was constructed in 101
And as you can
AD,
see, the frame rate
place
is
of the
pretty
Shilla
low.
Kingdom throughout its dynasty.
It's about 10 frames. And this is running 30 frames in my notebook now.
Oh, it's 30?
Yeah.
Okay, yeah. So that is what the
Yeah.
more right.
And it's really amazing to see the $4 million computer running this contents at 10 frames 5 years ago is running 30 frames in a notebook.
Right.
Actually, this pond actually still exists in Gyeongju.
Uh-huh.
And as you will see, the lotus leaves, as we go into the very near the surface of water, as you can see, the lotus leaves coming in sort of on the overhead, and it was in stereo, and people were trying to grab it, from the audience, especially the children. And it was very interesting to see how people react to images. But obviously you cannot really see that here.
Right.
Anyway, I'll just skip it over. So actually, that's almost the end. So this is sort of our plan for the future. We already have gigabit link to Japan, and we already have about 600 meg to Beijing. Of course, within our country, there's a multi-gigabit link from here to here. So we would like to have this kind of immersive digital experience all distributed. A guide may be in Beijing, the audience may be in Seoul or Tokyo. And they sort of have some shared experience of, and we feel that the role of guide is very important in cultural presentation, because the guide actually is the expert who controls everything and makes the content much more enjoyable than just the pre-packaged presentation. So an expert of that history and the heritage itself should be the guide, rather than just the authoring person who is doing it, the scripting. And always the same. Depending on the audience members, the guide decides which direction or which detail or which way to go, more responsive to the situation at the presentation. So we feel that this is a sort of a non-standard, it's not like a IMAX theater. So that's one of the difficulties of making this commonplace, because the interaction environment in each site is different, and but when we share the same contents, it's presented differently depending on their situation.
So how does this multi-site thing work with a guide? Do you have one guide for multiple sites, or do you have a different guide at each site, and you just share the data? Or, I mean,
Yeah, there can be many options, many
Right.
combinations, but our heritage of a live experience, we designed so that there's one guide, and there are distributed audience members that are physically distributed. Each maybe theater in Korea, a theater in Japan, being controlled by a single guide. And each guide group may be controlled by each travel group is controlled by the guide to have some. And this is sort of a commonplace actually when you travel to cultural sites. A guide leads you to different places, but there may be multiple groups, especially school trip. Multiple classes travel in different order and different details, and they come together and they may discuss about the whole experience together. And that's the kind of a setting we sort of envisioned in our Heritage Alive afterthought experiment after the Gyeongju. This is just sort of a plan for the future, and VR is no longer as big as before, but Japan Toppan printing company now is was very interested in this VR production, and they have a theater in Japan here, and I think still running, but we felt that multiple VR sites can be connected by high-speed network to have a this is their own content, this is our content, but maybe exchanged through common format and shared experience over different regions of the world. And we have some collaboration in Japan to extend this idea, and now it's becoming what we call ASEAN DHX. Now the more Japan and Korea and China are sort of meeting together on a regular basis to talk about this. This is a Japanese high school. We presented our heritage work over internet. No, I think I spent a lot of time. Yeah. Okay.
Okay.
I think I'm about half done, so I'll speed up.
Well, it just depends how hungry you are. We can have lunch after.
Now this is the sort of our current project on TSI concept. We call it immersive tangible experience. This project is the DHX is sort of like our previous experience, and this is our more current experience on tangible space, where we have immersive multi-channel display, a person, and this person not only sees immersive large multi-channel displays, visual displays, but also can feel the images through haptics. And this is sort of an international collaboration effort that resulted in the sort of complementary approach of haptics in Tokyo Institute of Technology and our research on immersive visual displays combined together to create more tangible immersive experience. This just started last year, so we have it's been about 1 year old, and the main focus here is the combination of immersive visual display with haptics. And in our local site, at our center, we have, you probably heard about cave system? Yeah. So we have our own cave. It's 2.6 meters square, and this was an open house in 2003. We built this cave. And this is the haptic device. This is string-based, and you can actually feel the stereo image with this haptic device, what we call Spider. So it's a 3 degrees of freedom haptics. So there are 3 strings attached to this common point, and you manipulate the stereo image with this spider to feel, not only see the stereo, but feel the objects with more tangible feeling. And this is the pagoda I mentioned to you about, the tall one. That this was the temple, about 10 times as large as Bulguksa, which is one of the largest in Korea now. And we use the various haptic interactions in this contents. And this is one of the scenes of hitting the bell with this, I don't know how to call this object with the spider. And we also are sort of investigating different ways of, especially autostereoscopic displays. But it's actually not a stereo right now, but it's a floating image with a haptic device. We're trying to design some floating image display merged with haptics. This is the scene of the... And we find that actually this was a negative experience because in a spider which with a large screen, actually your form factor is, compared to the image, is very small. That is, the image is the actual human scale. But because the lens we use is limited, the screen size is very small in this floating image. And so relatively your hand is much bigger compared to the image. So you actually have a lot of difficult times to see the floating image when you interact with this haptic device. So it should be mediated instead of direct manipulation in this kind of case, because your image is hindered by your interaction.
Right. But how would you present it then, the medium? I mean, I understand that humans are pretty good at handling that.
Right.
We know how to use steering wheels
Right.
and all kinds of things. But,
Right. So it shouldn't be in-situation interaction, but it should be mediated through
Right.
some other indirect interactions.
Okay.
Yeah. Otherwise, you will hinder the image.
So could you fix this by just making your image larger?
Yeah, but they will. Yeah, that's the same as cave case.
Right.
Yeah. But economically, this requires a huge size Fresnel lens, and it's not economically feasible.
Okay.
This is our. Actually, it should be called haptic glove instead of tactile glove, but excuse us for not using the proper English. But this is sort of we're designing a glove which is with the fingertip force feedback, and we are using what we call air muscle. So the airs flow through this tube to control the haptic feedback.
Well, this is quite sci-fi.
Currently only one finger, but
Right.
we are working on 5 fingers now. So hopefully we will. And the nice thing about this is very compact, and the mechanism is very simple.
Right.
So we hope to, compared to the what is commercially available, it's much lighter and simple.
Right. So would you have to have a separate host to each
Right.
actuator, or
Right.
would you have little valves?
Yeah, what they call air muscle.
Right.
Yeah. So this air muscle is very light and small,
Right.
and very high gain in force.
So where do you have the valves for the pneumatics?
Right.
Are they
The
on
controllers.
the head, or are they
Off.
off? Right. So could they be on the head itself, or are they small enough?
Yeah, this we are still working on that, and one of the main person on the air muscle development has just joined us. So
Okay.
we are working on this. This will be our main focus for one of the main focus this year.
Cool.
And the last project I'll explain to you, context-aware multimodal interaction UbiCom. Well, as we all know, the internet revolution has brought us the web, and now with the embedded computing and networking capabilities, the embedded appliances are on the web again, and this is the proper platform we feel to work on UbiCom. And the basic approach, we have the user in physical environment, interacting physical appliances here. And of course, these physical appliances are smart devices and with computing and networking capabilities. And we need to somehow collect all the states of these different devices to have some coordinated interactions with the user. And what we call context-aware interaction manager KIME is sort of like a middleware that looks at this domain, the interaction domain, and monitors the states and the different actual control commands that if available to these devices. And this middleware has an application layer that that is used to provide different services to the user. And this is the sort of a basic conceptual architecture we use in our UbiCom research. The KIME is the middleware platform we are developing based on the web service standard. And the obvious choice for our device middleware was UPnP. And this has been a good choice, and we feel that this UPnP can be scaled not only for some access points or some standard devices that currently widely used, but also in a lot more sophisticated devices like robots in the future. And the KIME provides the service through what they call context repository, which is basically the device states, collective device states that are collected over the UPnP devices. And we use the ontologies to have some higher level classifications of different devices, device descriptions, their states, and some common vocabulary to coordinate some services by the application layer. And this one, web service interface, is not 100% yet, but we hope to work on, focus on this area this year to have more seamless application development environment with KIND. Well, you know, the UPnP device works. So it discovers these different devices when they are plugged into the network, and then they collect their device descriptions and subscribe to their device states, and the control point may may send some control messages to the devices. This basic UPnP architecture. The context management by KIND is, I mentioned about the device states, but also we have the user activities that are inferred from user locations or user schedule and other things. And we have what we call context cube model to have some systematic analysis of user activities to design context-aware application service. And the context cube is basically a collaborative work by people in the design area and programmers. And this is a user activities matrix. In this, this is time and this plane. And this is a sort of a space and devices arrays in this plane. And these different devices and activities collectively are pulled together into a context cube to actually deliver the service with that context at that time. So, sort of, I'm sorry, this is Korean.
Okay, well, you might have to explain what is that.
This is basically user activities in a matrix form.
Right.
And this is the devices and physical space. So these different locations and different devices are pulled together into a particular interaction case, and they are strung together to have some sort of interaction patterns
Right.
within this context. So this
So the green represents a pattern or the blue is a pattern.
the collectively
Okay.
this arrows and these cubes together.
So you're saying that
yeah.
some kind of
Scenario.
context clustering
Right.
is a pattern.
Yeah, it's a sort of like a scenario.
Okay.
Yeah, and sort of people have a sort of a prototypical patterns of activities,
Right.
and depending on domains like home or
Right.
office or some other situation, we can have some sort of analysis like this for the programmer to design context-aware applications.
Okay, so what
Yeah.
you're doing is essentially you're trying to look at the whole space, what's going on, and then you find some clusters of related
Right.
kind of locations and activities, and then you say that one of those clusters, you identify the pattern if
Right.
it repeats.
Right.
Right. Okay, or something like that.
Yeah. So it helps the programmer to design the application service in different situations as a guideline.
Right.
It's
And
a-
it automatically finds the patterns instead of having to kind of
Well,
explain it.
eventually.
Right,
But
yeah.
this is sort of a framework,
Uh-huh.
and what they call in design, product design, they call it ethnography, where they have videotaping of a human subject interacting with different appliances, and they sort of analyze those different subjects,
Uh-huh.
some pattern of usage. And actually this was developed by one of the collaborators with us on product design.
Okay.
Yeah. And this is basically the web service interface we are developing at the moment. The protocol is already done, but especially the IDE part is unfinished. We have initial version on .NET of kind, and then we have a Java version, which is Eclipse. And what we eventually would like is an application programmer can collect all the devices in their development environment and program the application logic
Right.
in an IDE like development for Ubicon space.
So you're thinking visual programming or
It's
some
just
kind of
yeah,
programming.
like all these objects become variables with
Right.
classes,
Right.
and you just program the space with a particular application logic. Obviously, each user cannot be 100% programming, but at least for fast prototyping, this is an essential step for us to further the process of automation and intelligence. This message categories is just querying and service invocations. I mentioned to you about this already. The .NET version is based on KIM version. KIM is originally developed in .NET framework, and we use context repository for using ontology tool called Protege. And the application service is programmed in agent framework called, as you may know, the Jade. And we have developed a device simulator, UPnP device simulator, which we can have all the physical devices. So we have simulations
Right.
of different devices.
Well, at least it's easier to get
Yeah,
things going.
to create new devices and so on, all kinds. And the context monitor that keeps track of the device states and display the states with what we use Visio that has a sort of a home environment. It's a floor plan of a home environment where different visual icons are represented as UPnP devices, internally processed by simulator, but represented as the visual icons in Visio.
Right.
And the device spy is to control the UPnP devices. We didn't have a web page control interface. We just used device spy to control
Okay.
it. And mainly in the home environment, we have analyzed through the product designer various activities. We didn't implement everything, but we implemented some parts of it. Enter home, watching movie, dining, washing, and sleeping. And this is the basic components that we show in this demonstration. I'm sorry this is very fuzzy and hard to read. Just get us some idea. This is the Visio floor plan of the home, and this is Kine. Oh, this is the Jade agents. They are used to provide some context over services. And this is a device simulator that brings all the UPnP devices and collected by the Kine.
Right.
It's a universal control point of all the UPnP devices in the domain to collect all the device states and universally control all of them. And the service agents sort of monitors the context repository to see what the states of all the UPnP devices in the domain, to bring about some services that are intended for that particular agent, the service application agent. So in this case, we are the clock as a UPnP device. We are sort of setting the current time, and the user is this guy here.
Okay.
And it's about to enter. And this is different appliances that are in this UPnP device in the domain. And the user is about to enter and recognize that the person is entered the house.
Okay.
And based on that activity, it turns on the living room light. And when the person is in the living room and sits on the sofa, it sort of proactively turns on the TV as an intended service for the user actions. Actually, here we are setting the device states through Intel device spy. And this is sort of, we are virtually simulating the person is walking inside the house and moving to the kitchen and recognizing that the TV program should be moved to this kitchen and the light should be on and so on. These are sort of pre-programmed services upon recognizing the user activities. So this is basically the whole routine when the person get off work and come home and go to sleep. That's the basic activity scenario for this demo.
And there are various tasks you do before that. Right.
after recognizing he's going to sleep, then turn off the light and so on.
So the going to bed is like one pattern, for example.
Yeah,
or
just
like
yeah. This part is what we call multimodal interaction. For multimodal, we could mean either human sensory modalities, where a user may use speech or gestures, but also other kind of sensory modalities for tracking. It can be vision-based tracking or sonar-based tracking or some other types of sensors used to track or sense some moving object as using multimodal sensory data. And the KIM here, although they are not fully integrated, they are being separately developed as an infrastructure support within our center. One is the vision-based tracker that is being developed with multiple cameras that is placed in the different areas in our center. And the other one is more concentrated, fine tracking. We call it smart floor, where the floor is instrumented with force sensors. So it senses pressure. And we have you heard cricket? Cricket, that it's
That's the MIT system.
right, right.
The guy actually works at Microsoft now.
Oh, okay.
Bodie. And he did a lot of that work.
Uh-huh.
So, who does he work with?
He is one of the mobile.
Oh, okay. Yeah.
So we have over 50 beacons all over the place in our center to make use of this cricket-based tracking. And also the Wi-Fi-based tracking system that was developed in Intel lab here in Seattle. So sort of like multiple different modalities that are being instrumented into our space to have indoor tracking. I mean, the outdoor tracking is mainly by GPS.
How are you handling uncertainty in context-aware interaction management?
Well, that's many people use Bayesian network to evidence-based probabilistic reasoning. Instead of going right into the research of Bayesian network, we felt that we should have a very good data before. We should have a very good collection of data and from the interaction environment.
I mean, the problem is that this is
Yeah.
the idea of combining many tracking systems together is very nice. You have a lot of, it's a very nice system. Having all those things together, but they each fail.
Right.
So you have to, at some point.
Oh, yeah.
You have to do that.
Sure.
Or to
Yeah.
decide what it really is. Right.
Yeah. So the obviously different sensors have different operating regions within the space. Not only the physical space where they are instrumented, but also different strengths in terms of the uncertainties or certainties, or line of sight, maybe occluded, and so on. Those are very interesting questions to address, but we felt that before doing all that kind of sort of story-based, some sort of problematic cases, we built the environment first, and then in bringing about those context-aware services, we deal with those combining issues with, but that within that particular service context. Obviously, this is not much progress to that direction yet.
But you said that you have different ways, so you can essentially have some kind of a voting system or whatever.
Yeah, I mean, there are many ways of evidential reasonings doing that,
Okay,
and
but it's in
probabilistic
progress.
distributions and so on. But in order to make that really useful, you have to have a good data to analyze the user activities in a particular framework to have more knowledge-based guidance to the interpretation of the data.
But I think Andy is right that it's also an interesting
Right.
problem domain that you
Sure.
have uncertain data.
Yeah,
and,
the sensor
how
fusion is
you
a big
reason
issue
about
here.
that, so-
Yeah, and most sensor fusion work, well, successful one, has been addressing particular fusion based on particular purpose in mind, and these different indoor tracking systems. Each one, we are at the point of each one working, and then combining them to make them their strengths and weaknesses complemented. That part we're still working on.
Right.
And this is a smart floor, and this is a sort of an instrumented room where we have many projectors and floors with instrumented with pressure sensors, and the walls are covered with display screens, so you have more of a large cave, essentially. So this is sort of just a system demonstration and of making use of the projectors in the ceiling and the sensors in the floor to control the contents. Obviously, you can use it for controlling the contents, but also you can use it for different purposes, for tracking or some other type of interaction. It's in the same room where we use vision-based tracking instead of the pressure-based tracking. And obviously, as you mentioned, that we make use of these different tracking systems in this room to be combined in certain way to complement each other. But we are in the stage of working on individual sensory modalities. This is the corridor in our center where this is not automatic. User is as a video surveillance purpose, and looking at different camera views, you sort of give the direction of where the different cameras should look, and these cameras can be coordinated to see different regions of the corridor, or track some person, or identify some person. We would like to make this more automatic, and make use of different modalities to complement each other. Yeah. For example, we have all the cricket beacons located in the corridor, which can give you the rough locations, and then we can sort of zoom into the person with a video surveillance system. That's an application service. This is the cricket that I mentioned to you. And we have these different regions where the cricket's located. This is only showing part of it. This is sort of a conceptual video of service we are planning on implementing in our space, what we call follow me, follow you service, where a person called in to make an appointment, and at the appointment date, the person is, well, we are assuming he's carrying the cricket listener. Okay, so he's recognized, and the video is paying attention to him, and the person is receiving the video image through PDA, and he's commanding the system to move the image to the large display and make the conversation with the visiting person. Sorry about the image quality. So he's showing where to go, the meeting space, meeting room. This one, the PDP shows the direction for the visitor, and this is the application of follow you service, where we have pointed him as a main person to videos in the environment to follow, and he's looking at this person is arriving at the meeting place, and the other person knows now he can greet him at the meeting place. So we are instrumenting the space with the location tracking and video surveillance and media streaming in any-to-any casting that we could provide some context-aware services in this environment. So these are some of the application services we have in mind: the telemeeting, environment control. I think the presentation is already here, is very heavily instrumented here. Right. And media service. In the future, I started out this talk with digital heritage as a virtual exploration of the cyberspace in a tangible way, and then we ended with Ubicom, where the user interaction patterns being analyzed and bring about the context-aware services, and we need to have some sort of a the pattern of behavior knowledge about the person or the society in general. If it's very general enough to a large group of populations, we call it culture. It's a sort of more of a some fixed patterns of human behaviors that can be safely programmed into the context of our service within the different groups of people with the different cultural biases. And we are looking at the sort of larger populations being their interaction patterns in a Ubicon environment can be logged to see the common patterns by group of people more reliably. And as you may have heard about the MIMEX vision by Vannevar Bush in 1945, he envisioned this desk is a sort of a super device that stores all these books and records and communications that is carried out in this desk, and then you can browse through them in a full text search and annotate different audio, video, not video at that time, but text and hyperlinks in 1945. And we are very near to achieving this, and Microsoft is doing a lot of research in this area. And I think this is our future direction to go. Well, thank you. That's the end.
Well,
I'm 10 minutes late.
Well, we started a little late too, so that's good.
Thanks.
Thank you. Thank you.